Okay, I know you're getting really excited to start deploying our contract, but if we don't test it, how do we know that it is working as intended and that there isn't any edge cases, any loopholes where other bad actors can take advantage of because of a silly logical error in our smart contract code? Ready to write some tests? Let's do it. Okay, so as usual, back in our IDE, we now have the test folder. In it, you probably should have test_coin. That's something we did in a previous video. So test_coin is kind of our first attempt at testing our smart contract. Today we're going to create another one. We're going to say test_, and to name it after our contract, it's called ballot. So test ballot.py, just to give it the same name so it's easily recognizable. This test file is actually for the ballot contract and coin is actually for the coin contract. So as usual, this is what we're going to do. We're going to close out this sidebar. We're going to have ballot.sol open up on one. So on the right hand side, we have our Solidity code open up, and on the right hand side, that's our Pytest. So this is where we write our Brownie test, and this is where we can use as a reference. So what we're gonna do is very similar to what we have done, which is to go through from top to bottom and make sure we test. Every time you see there is some sort of function, some sort of if-else logic, some sort of loop logic, whatever it is, right? You want to make sure that that is actually being reflected in your test code. So to begin with, let's go ahead and just import Pytest. This is something that you've probably done a couple of times already. So next we're gonna import Brownie. So we say from Brownie import. Okay, what do we have? Our name of a contract. Name of the contract. If you look at your build file, if you haven't built your file, you want to make sure you did the Brownie compile. Okay, so I want to say Brownie compile, and that will build your contract. Then if it's built already, you should see it in your build folder. Within contracts, you should see this is ballot.json. So we have that already. We can just import that. And we know we need some fake accounts anyway. If we don't have some fake accounts, how are we gonna transact and test things out, right? So let's go ahead and create some fake accounts, and I think that's kind of it. So if you look at test_coin, we did something like pytest.fixture. This is pretty smart because we don't have to repeat the same line of code all the time. So we are probably gonna steal that idea, bring that into our test, and instead of coin.deploy, we're gonna say coin. We're gonna say change that to ballot. There is the pytest.fixture. That's where the Pytest is coming in, and then we have the contract. We're probably just gonna call it ballot to be more explicit, so we don't get confused about what contract is referring to. Okay, so there is the ballot, and that tells us that it's an instance of the contract that we deployed, of this contract that we deployed. So if you look at ballot and you look at the constructor, you see that there is a little bit different from how we initialize the coin contract, because here it says that when you first initialize it, it needs something. What does it need? It needs an array of bytes 32. Okay, so it needs an array of bytes 32. And what do you store in that array? Well, you store the proposer's names. So you have the proposer's name. And typically in the blockchain world, in the smart contract world, you don't have like long, you would think that, okay, I would probably have something like upgrade network to fix vulnerability relating to re-entrance. You would think like this is a good suggestion for a good proposer to re-entry. But this is not, because this is using a lot of gas fee just to transmit that there's a ton of string, and then to store them, there's also a lot of cost involved. So typically what we do is that we represent all of this using proposers IDs. So you probably have seen this like EIP. So this is kind of, let's fix some and just use those as proposers. So we have proposers. We have some proposers like 1007, 1014, 1021. This is just an increment of 777. To give you an example of what I'm talking about, if you search up EIP proposers, that's the Ethereum Improvement Proposers, and this is EIP. And if you look at Ethereum Improvement Proposers, you see that it starts from EIP 1. This is how blockchain engineers agree to incorporate changes, to propose new changes, and this comes in the form of that. So EIPs describe standards for the Ethereum platform, including core protocol specifications. These are the terms that you come across: idea, an idea that is pre-draft, this is not track, draft, review, and all of these are proposers, and anyone could make a proposer. So if you look at the proposers, you see these are all the proposers in here, and they are all given a certain ID. So you have, for example, EIP1, and you click into it, it says that EIP1, what is the purpose, what is the guidelines, what is an EIP, and it says EIP stands for Ethereum Improvement Proposal. It's a design document providing information for the Ethereum community describing a new feature for Ethereum. So this is kind of a proposer which is perfect for what we're doing here, right? A ballot is where people could maybe vote in favor or against the proposer. So an example of a very popular EIP is EIP 1559. This was implemented August 5, 2021. This is also called the London Upgrade. It changes Ethereum's market mechanisms for transaction fees. If you want to read more about that, I'll leave a link here. You can go to learnblockchain.academy and you can read more about what does this do. And here you see that the base fee is burned, removing from circulation. So obviously this is not an easy choice. This is not an easy decision. There needs to be some sort of consensus. So when a proposal is put forward, the community comes together and decide whether or not you want to take that onto the next stage. So going back here, we have proposals, and then we create 3 proposals that people can vote for. They can vote for whether or not they wanted 1007, 1014, and 1021. Okay, so 1007, 1014, 1021. It's just some random numbers that I thought about. and you can maybe have more proposals and folks can vote for in favor of one. So what we have here is if you voted for one, you can't vote for the other. All right. So this is kind of set up. It's trying to deploy the contract. And if you look at the constructor, it says that when you first deploy the contract, it needs to take a list, not a list, but an array of bytes 32. So how do we go about doing that? Now in our code here, this will not work anymore. If you try and deploy that, you don't have the constructor. So what we need to do is to put the proposals in here. So these are where we put in our proposals, and that is going to be used here in the proposals. And then they're just going to take each one of them. So there are 3 proposals, each one of them going through this for loop. And while it's in the for loop, what does it do? It creates a proposal. This is the struct that we created right up here. And what does it do next? It says push that into the array called proposals. So we have the proposals. Within that, it's going to store an array of proposer. And within each proposer, there are going to be name. There's going to be the vote count. And the name is going to be initialized to this one, right? While the word count is going to be initialized to 0. There's just no words on each one of them, right? So this is kind of how we would set that up. If you were to run this, Brownie is going to be smart enough to take that and then make sure that it's going to be the bytes 32 type. But if you want to be more explicit, then you can go ahead and just do a convert. This is optional, but you can choose to do that if you want to. So I'm just going to go ahead and do that just to make things more explicit, right? So what I can do is I can say take, maybe have the bytes proposals, and I can use a list comprehension. I can say P, or maybe say convert to bytes. This one, P for P in proposals. So what this is going to do is to look at each one of them. So for P in proposals, what does it do? It says convert to bytes. So now I have bytes. The default of bytes would be 32. It says here, you see string equals to bytes 32. If you want to convert that to another 64 bytes, whatever, you just want to put a comma and then you specify that. But because it's by default 32, and that would be the same as what we have in our contract, so that is good enough for my purpose. So I'm not going to have to write that manually. And now we need to change byte proposals, move this in here like this, save it. So now we have the Pytest feature. So every time we write the test now, if we write a test here, test something, if we take ballot and we put that in here, now ballot will be created, this fixture would be run, and we can have access to that. Okay, so let's take a look at what we want to test first. If you go all the way back up, we follow a very systematic approach. We have been following the same approach. We scan it from top to bottom, and we see all of those things here, and we said, okay, what do we need to test? Just looking through, top to bottom here, and maybe run it line by line. And then if there is something you need to test, you write the test here, and then you can insert your test. So for example, the first thing I saw here is that there is a constructor. It occurs to me that this is kind of important to test. This is something really important you want to test. You want to make sure that no one should be able to set chairperson, and chairperson should only be that person who deployed the contract, right? So let's go ahead and say test set correct chairperson ballot. And what do? We say assert. If we deploy this contract, it deployed from the first account 0. So that's the first account in our list of accounts. There will be 10 accounts. The first account is going to be account 0. And we want to assert that the chairperson is actually going to be account 0. Because if it's not, we're in big trouble. We want to make sure that ballot.chairperson would be the same as account 0. So that's testing for the first one. This should pass. If this doesn't pass, we in deep trouble, because now we have some other there's somebody else who can be a chairperson and would give out votes and stuff, and that would just corrupt the whole economy, and that's not good for our smart contract. So we don't want that. Now the next thing we want to do is we scroll down a little bit and we see, okay, what else do we have? What if we just test this? We say constructor, since you asked for a list of proposals, I want to make sure you're doing something with it. If you ask for that in your constructor function, you want to make sure that you are using it some way. So why don't we test whether or not that is being used? So let's go ahead now, say define test, and we want to say that since we spin up this smart contract, we deploy that, it should have 3 proposals, right? So let's go ahead and say test has proposals. Same thing, valid. Now the valid contract has already been deployed. So what we can do is we can just test. One thing you can do, one idea you have, is you can test for length of proposals and see whether that's equal to the length of this length of the whatever is being returned. So you should see that it's going to be 3 because we have a total of 3 proposals. But in order to do that, you need to first have a way to get the length of that. So you want to do something like valid, and then you want to say get length. But we don't have get length. So one way to have this behavior is you can go all the way up here and just create some getter functions. Maybe after constructor, you could have something like function. Let's not call it get length because it's too vague what it's doing. Let's call it get proposal count. And we need this to be a public function, and this could be a free function if we just define it as a view, because we're promising not to change anything, not to alter the state of anything on the blockchain, right? So public view returns, and this is where you return. And in this case here, where's the count? I mean, you can just, it can just be anything, just in count. And here is where you return the length of the proposals. Where is the proposals? That's here. So we can just say return proposals.length. If you do this, then you now have a view function that you can use, and you can just say get proposal count, and you can then assert that the answer of that, the result of that, the value of that would be the same as the length of this one, proposals. Just copy that, put it in there. But we don't actually have that in our original contract. So this is one thing you can do. You can go ahead and redeploy the contract. You can recompile the contract, and then you can write your test here. Because I don't have that and I don't want to recompile my contract, what I'm going to do instead is we're going to just try and maybe take the first few values and see whether or not it gives you the exact same thing. So the first value is 1007. Want to make sure that on the contract, the first proposal is also 1007. So how we do that is we can say, if we go ahead and say valid dot proposals, that will give us this list. And within the list, we can ask for a certain, so this is it, right? Proposal. We can ask for a certain index of that, right? We say, okay, what if we just take the third one? Or the third one would just be 2. So 0, 1, 2, that would just be a third one. Okay, so this would be the third proposal. And it would return what? It would return name and vote count. So you can have something like name, vote count equals to that, and you can then check whether the vote count, whether the name would just be 1021. But you will need to convert the unit. So you can say something like convert and to integer, and with what? Name. Just put the name in there. And here you're saying that convert to integer name, and you want to make sure that you assert that to be 1021. Or actually, let's not hard code that. Let's write proposals too, like this. But if you want to do it for all of the proposals, you can also do that. Now we know that it returns a tuple of 2 values, right? Name, vote count. So you can also just try to be a little bit more efficient by just taking all of this and put this in here, and then take the second item, or the first item rather, because the first item would be the name. Not, you don't want a vote count, you want a name. So this would be the third proposal. This would also be okay, right? So what we're doing here is essentially saying that there is 2 things being returned, 0 and 1. The first thing is the name, the second is the vote count. We don't care about the vote count now. We only, for this test itself, we only care about the name. We want to make sure that the name is the same. If you convert the bytes to integer, it would be that. So this is going to be returned in the bytes. format, bytes 32. So you want to make sure that's going to be converted back to integer, and then you want to check for that. Okay, so that's the proposal. What if you want to do it for the other proposals? Just copy up a couple of times, and we can do 0, can do 1, and in here we can do the same thing, 0, 1. So this is going to check whether there is exactly the 3 proposals. So if our contract constructor work as intended, we should be able to then have all these 3 proposals returned to us, and we should be able to take the name attribute and we should check that they are the same as the one in proposals if the ballot constructor function worked as intended. Then the next thing, we scan down a little bit more. So this is constructor, we see that okay, that is being set. So this is us, this is our own, this is the admin, the person who deployed the contract. We want to make sure that that person already have rights to deploy anyway. And from here it says push, okay, so we have that. Now that let's assume this is already done. Maybe there is something else we can test for, but let's assume this is done. Let's move on to the next one. The next one is what? Give rights to vote. Function give rights to vote. And it takes an address and it would just give the person of that address a weight of 1, meaning okay, now you have the rights to vote. So let's go ahead and write some tests for this as well, right? So let's say def, and we say test rights to vote, but assuming we're acting from an admin, and we say ballot pass, because why I do pass is that I know I wanna, when I write in this paradigm, I know instantly that I want to test for 1 when I'm not admin. So I'm not an admin, so like this, right? So when I'm not an admin, what should happen? When I'm an admin, what should happen? So in this case here, I want to just say ballot give right to vote so taking a contract ballot, calling this function give right to vote, it asks for an address. So I'm gonna say give it to the first guy. Okay, so this is our collaborator. It's kind of the same idea that we have from last time, and we're gonna say from, that's basically us, so counts 0. Right? So we're trying to give rights to vote, and that should work. And how do we know that should work? Well, if we checked for that guy, we said ballot voters, and let's take a look at what we have in voters. Well, again, it's a mapping, so we need to pass in an address, and it will give us the voter struct itself. So do we have the address? Yes, we do. Just have to copy this. You can put address if you want, but Brownie is smart enough, you don't even have to do that. So you say, if I check for this guy now, I should see that the person, in fact, have a weight of 1. Right? So it returns 4 items. So it returns delegate, vote, weight, and voted. It returns 4 items. But really what you need is just weight. So you can just assert weight equals to 1. So this is kind of how you test and said, hey, if I give you rights to vote, you should be able to vote now. So one pattern you see is that if you don't need any of this, you only need this, you can just do a underscore, underscore, underscore. Just an unnamed variable. So you can, here it's essentially the same thing. This is maybe a little bit cleaner. You're saying that there are going to be 4 things that are being returned. There is the delegate, the vote, the weight, and the voted. We only need the third one, so we just say comma, comma, and this. So assert weight equals to 1. And what about if you're not an admin? What if you're not an admin, what do you want to do? This is kind of the same thing that we've done in the last contract. So you want to just bring the revert back in here. So revert. And within this, you want to say with reverts. With reverts, what do? You want to try and give. But now, you want to make sure this guy is not the admin account. So maybe the first guy. So, or you can say the first guy giving to the second guy. Whoops. Like this. Alright. Did we misspell it? Reverts. Alright. So that would just try to take account number 1, give rights to vote, call that, and give it to account number 2, and you want to say that that shouldn't work. Okay? You want to say that shouldn't work. If you want to, you can also go ahead and test and say, assert that after this operation, you want to assert that below ballot, you want to assert that ballot, voters, copy this. You want to make sure that this here has no weight on the attribute, has 0 for the weight attribute. So you can follow the same paradigm here, or because this is 0, this is 1, this is 2. So I know that if I take the second item, that would just be 0. Take this, take the second item, so that is the weight of this, and I'm going to say that's going to be 0. Okay, so just want to assert that's true. So if after this operation succeeded, then you should see the weight becomes 1, and then this whole thing would fail. So you want to make sure that if it's a non-admin account, if it's not the chairman, you can actually, instead of admin, I should probably write chairman, but it's probably much longer, so I'm just going to call admin and non-admin. But you know what I mean here, alright? So we're going to save that. Let's just very quickly go and do a Brownie test just to see that everything works first. So let's say Brownie test. You see that what's happening here is that it's going to test for Brownie test ballot and then Brownie test coin. So that's from our last contract. And now in total we have 11 tests. And we really don't want that. I just want to scope it down and say, no, actually when I say Brownie test, I just want to test this file. So I can do that as well. I say Brownie test and the name of the path to this file. So in here it's test/test_ballot. So test/test_, whoops, ballot.py, save that, run that. Now it's only collected 4 items and 4 items passed in 1.14 seconds. So that's better. So we're just gonna test for only this particular contract. We don't care about the coin contract anymore. We already have 100% coverage on that, right? So let's go ahead now and see what else do we have. Test contract, test rights to vote, non-admin, test give rights to vote. So that's here. What else do we have? Well, every time you see a require, you also want to test for that. You want to see that the require is actually coming and interrupting the process and reverting the whole process if the condition is actually being met. So first thing here is if I want to test for when the sender is not the chairperson, that is what I'm doing with line 30. That's my test function here. Then the next one is when the person has already voted. So the voter has already voted, that should also fail. So we should also go ahead and say def test rights to vote has voted. So we now want to test for line 44. Okay, ballot. And we want to copy pretty much same thing here, because we know it's going to revert. We want it to revert at least. And what are we going to have here? We want to say that, okay, if we first give this guy the rights to vote, so let's go ahead and copy this one. So if we give the first guy the rights to vote, but we take the first guy and we use the first guy to vote on something. So let's say ballot, vote, let's say vote on, he is in favor of 1007. So the first one. So let's say 0. Now it's not from account 0 anymore. Now it's from accounts 1. So what this is doing is saying that, okay, the chairperson have given the rights to vote to account number 1. Account number 1 take that and exercise that right by voting on proposal 0, proposal index 0. And once this is done, this person would have already voted. If you repeatedly give somebody the rights to vote, you're actually going to keep hitting this function. And what ends up happening is this guy's weight is always going to be incrementing. Of course, we have to check here as well, so that wouldn't happen. But still, it's not a pretty good idea to just have somebody to just keep accessing, just requesting for rights to vote and then incurring gas here and there, right? So you want to make sure that doesn't happen. And if you don't have this, then it's especially troubling, because the person, through doing this, not just incur a lot of gas, but can also artificially increase the amount of weight this person is having. So this guy is going to have a weight of 2, 3, 4, 5, and then you can delegate that or can vote and have outsized influence, and you really don't want that. So having these 2 checks are pretty good. It's kind of saying that, okay, if this guy has already voted, you cannot request for this. This function will not run anymore. The require will not pass. So you want to require that this person have 0 before you assign it to 1. So this is also when we can write the test to check for this one. So here we're going to call it that def test rights to vote, and we say that this person has rights already, because you already have rights. That's the reason you don't get a 0 in your weight. You must have already have rights to vote in the first place, right? So we're going to say test rights to vote, and we say has rights. So kind of telling us that this guy already have rights. So he already have rights, and what do we do here? We're going to do the same thing. We're going to say take the first guy, which is the admin account, give rights to the first guy, and from here, if we were to try again doing the same thing, so with reverts, if we try that again, it should just revert, because hey, you already have rights. Why are you asking for rights again? In fact, if you want to, you can even simplify this to just have the reverts and show you what I'm doing here, to just have this to 0, 0. Meaning the first guy already have rights to what? Should just fill. Something like this. Something like this. So you can just say, hey, if the admin is trying to give rights to what to the same person, then just revert that. You don't even need to incur any gas fee, because just revert the whole thing, because you already have that. Why are you still asking that, right? So you can use require to cache for that. So you can also do that. I misspelled ballots, so make sure that that's ballot. And did we complete all of the give rights to what? I believe so, but if there isn't, we can come back to it, no problem. Let's save it real quick. Let's run Brownie tests. Okay, 6 out of 6. Well done. Let's move on to delegate. Okay, so in delegate, let's take a look first. It says here that require that this person have not voted. If this person has voted, you should not be able to revote again. So let's go ahead and do the same thing. Say define, and instead of test rights to vote, we're gonna say test delegates has voted ballot. And what are we gonna do? We're gonna say that, okay, if the first person, if you have already voted, you cannot vote again, right? Cannot delegate. So we're saying that, okay, if we gave account number 1 the rights to vote, and account number 1 used the rights to vote already, he cannot delegate to another person. Okay, so let's go ahead and say, okay, give right to vote. So let's copy these 2 lines of code and bring that down. So this person has voted on 1, can vote it on index 0, so voted on this proposal. And once you're voted, you should not be able to go ahead and pass it on to someone else, right? So let's do a reverts as well. What do you want to revert? You want to say try and take the delegate function. So delegate function asks for an address. So we don't have an address yet, so let's just use accounts2. And we say, okay, if accounts1 want to pass it to accounts2, so let's put a from. So this is your message.sender. And it should fill. And it should fill not because accounts2 doesn't have the rights to vote. So we need to be more explicit here, because if this condition is satisfied, even if it filled, we are not 100% sure that it's because of the delegates having already voted. We don't know that. Maybe it's also because account number 2 doesn't have the rights to vote. So how do we make sure we are more clear on that? We said, well, take away that possibility. So we gave the rights to vote to the first guy, and we give the rights to the second guy as well. And so there is no possibility of accounts 2 failing because of a lack of privilege. It must have been because the first guy have already voted. So you want to think about that when you write your test. And let's take a look at the next require statement. It says require message sender is not to. So you cannot delegate to yourself, right? So this is also, we can, in fact, I think we're just gonna copy most of it, paste it here, and we say delegate, task delegates, this should fill because it's trying to do it to himself. You're trying to delegate to yourself. So I'm gonna pass it to account number 1. We don't need this anymore. So we're gonna delete this, and we say with reverts, you're trying to give it to yourself again. So this. So here, you're given the right to vote, but this is the message sender. We're saying take this and call the delegate, and what is the address to? Yourself. That is not logical. You're trying to delegate to yourself. I mean, that is probably logical. Maybe you're trying to work around a system or something, but here we're trying to say, no, you can't do that. You can't delegate to yourself. So you cannot delegate to yourself. This is what the condition is checking for. Okay, that's cool. Let's do another one. Let's copy this again, paste it down here, and now let's check for the next require statement. We have this require message sender found loop in delegation. Okay, so we don't want to have A pass to B, B pass to A, right? So how do we actually avoid that? So we need to give rights to vote for the first account and the second account. That's okay, but then we want to have the second account. So I want to say ballot, and want to say delegate. I want to say the second guy. Let's say we want to say the first guy delegate to the second guy, and then the second guy try to delegate back to the first guy. All right. So let's say this. And we have from accounts 1. So we're the admin. We're giving the rights to vote to accounts 1 and to accounts 2. Now we're saying that accounts 1 is calling the delegate, passing it to accounts 2, and then accounts 2 is doing the opposite now. by calling the delegate back to account 1. So we also don't want that to happen. Maybe somebody's trying to find some loophole and trying to vote multiple times on a certain proposal. So that shouldn't happen. And what next? We have the storage, we have require, another require here. It says that the delegate should have a non-zero weight here. So if that person is not eligible to vote anyway, then this person is disqualified as a delegate. So let's go ahead and say test define test delegates, and this is no weights, so let's say no weights, and ballot, and whoops, we're gonna copy the same thing here. We're gonna give it to the first account, and we're gonna say if this person attempts to give it to the second account, like this, then it should fail, because accounts 2 have no rights to vote yet. We haven't actually done that yet, right? We didn't perform the give rights to vote on the second account, so this should reverse. And by the way, if you look at the documentation, and I just took a quick look at it because I suspect something was wrong, you realize that reverts should actually be like this. So we want to find all the reverts. We can do this really quickly by saying this, and then we can just say replace all with reverts like this, and you can just say replace all. So replace all is Control Alternate Enter. If you do that like this, now all of that is going to be replaced, and now you have the correct reverts. So some of them, if you copy from the top, you probably don't have the proper one, so you want to do that before you move on. So now we see that, okay, now reverts is fixed. And you also want to fix the naming here. One of the copy that we did, we said test delegates has voted, and we put in the same name. This is not correct. So this is trying, what is this scenario? This scenario is saying that, okay, if the delegate, if the person A, or if wallet A is trying to give it to wallet B, trying to delegate to wallet B, and wallet B is trying to delegate back to wallet A, that also doesn't work. So this is actually not called has voted. This is actually going to be something like in loop. Okay, so you're trying to say, no, you don't want to do this in a loop, or you can say to loop, up to you, right? But it's saying that you cannot delegate to a wallet only to have that wallet delegate back to you. So this should also reverse. So if we save that now and run our Brownie test, we should see if there's any other errors we should be catching. Okay, 10 passed so far. All right, so now there is the no weights, that is this condition. What else is there? We want to see that, okay, if all of this require statement has passed, then there's some set state that we need to do, right? There's some state that we need to alter. There's some state that we need to alter or modify. So sender.voted, we want to set that to true. Delegate, we want to set that to the address of this person that we delegated to. So let's go ahead and say def task delegates, and we say if this is successful, then what should happen? Delegates, if it's successful, you want to go ahead and do some set state. Ballot, and this is what we want to check for, line number 72 and line number 73. Okay, so let's just go ahead and do the same thing here. We say, okay, give the rights to vote, and then do the same thing for second, because we need the second to be able to set that in here in the line 73. Then what we do is we say, okay, take the first guy and delegate. So try and copy that, bring that down, and we say take account 1, pass it to account 2, delegate that to account 2, and then from here we can just try and take, let's take a look at what we have. If we look at voters is going to give us this, and then we just have to find all the 4 items. Okay, so let's do delegate, and we have vote, we have weight, we have voted, and that should just be ballot. The voters, now voters is basically a mapping, so it takes an address, and then it returns the voter struct itself. So where is the address going to come from? Now the address is going to come from this. So I'm going to say take this, copy that, paste it in here. All right. Now what do we want to check next? We want to say that if we look at our contract here, this is the delegate, the set state. It says that the voted should then be set to true. So let's first test for that. So let's say assert voted, that should be set to true. Okay, what else? Sender.delegate should be to the 2. So let's test for that as well. So delegate accounts 2. You can also have accounts 2.address, but it's the same thing. Brownie is smart enough to know that. So we have the delegate success set state, then what else is happening? So what else is happening is that, okay, if all of this pass, the state has already been set, what next? So what next is two scenarios. The first scenario is that what if the guy has not voted for any of the proposals yet? So let's maybe check for this scenario. We say that define test delegates not voted yet, because that's the first scenario. We know that we also need to check for the other scenario, so might as well just go and create the test first. Delegates success. Oh, let's make sure it's success here as well. But this time this person has voted, so has voted. Okay, so what should happen if the delegate is trying to vote but have not done so yet, right? So let's take a look. Let's try to give rights to vote first. Copy that. It's always going to be the same anyway here. We're just trying to give account number 1 and account number 2 the rights to vote. And also try to just fix this real quick. Okay, and then once we've done that, we want to make sure that the first guy delegates to the second guy, kind of the same thing up here. So we're just going to copy that as well. So first guy delegates to the second guy, and what else? Let's also just copy this maybe. Bring it down here. So what do we want to see? We want to see that if the person have not voted, then the delegate should just have an extra amount of weight. How much? Well, whatever it is on the sender side of things. So if let's say person A delegate to person B and person B delegate to person C, now there should be 1 plus 1, and now there should be 2 plus C, it should be 3, right? So in the case of this, we have accounts 1 delegating to accounts 2, and accounts 2 haven't yet voted. So what should happen? The weight should just add the first person's weight, the account number 1 weight. And so we should just do a quick assertion here and say assert weight equals 2. And the rest we can just keep it as underscore underscore like this. Right? And you can also have the case of having actually 3 accounts. So account 1, account 2, account 3, and let's say account 1 and account 2 both delegate to account 3. So account 1, account 2, account 3, account 1 and account 2 both delegate to account 3, then what should be the case here? It should be 3, because let's see, weight accounts, if we check for the accounts, we should check for the accounts 3, because that's this guy. Right? So accounts 1 delegate to accounts 3, accounts 2 delegates to accounts 3, so 1 plus 1 plus 1. So this guy should now have a weight of 3. So whoever is it that he's backing, that should count 3 times as much. You can also do that if you want to. If you want to just have an extra layer of delegation, you can do that. But what about the other condition here? What about the other scenario? It says that proposals delegate vote count. If the delegate has already voted, what should happen? Well, if the delegate has already voted, the weight is not going to change. So this weight has no more, it has no influence on the weight anymore. Instead, what should happen is the proposals, that should change, right? So let's go ahead and maybe just do the same thing up here first. 1, 2, 3. If you want to change things up a little bit, let's maybe say instead of giving rights to vote to 1, 2, 3, yeah, we can do that. But we definitely need to have the delegate having voted first, because this is the condition we want to check now. We're saying that if the proposer already received a vote from the delegate himself, then this is the else condition that's going to run, right? So let's go ahead and make account number 3 vote for something. So let's say vote, and let's vote for, let's say proposal number 2, okay, which is the final proposal, because there is the proposal 1, proposal 0, proposal 1, proposal 2. So let's say voting for the last proposal, right? Vote for 2, and it needs to, this needs to be in the form of a transaction, so it needs to go from accounts, let's say accounts 2. Okay, so accounts 2 is the person, we trusted that person, but this person has already voted. Now we try to delegate that. So let's go ahead and do a delegate. Take this, and we're just going to copy that, bring it down, and we have account number 1 and account number 3, each one of them delegating to account number 2, like this. So this would hit the condition. The delegate has already voted, right? But now, after the voting, accounts 1 and 3 decided to delegate to accounts 2 again. So this is where the else block is going to run. So what do you want to check next? Well, you want to check from the proposals itself. So ballot.proposals, which is right here. I think we've done that before, ballot.proposers. Just like this, we've done this before. So we're gonna go in here and we're gonna try and say ballot.proposers. Now, which proposal are we looking at? This account. Just to actually make things a little bit more clearer, I'm gonna say that this is the account that we're working with. Proposer equals to 2, and we're gonna say proposer, take this, replace this, we're gonna say this guy works for this proposer, which is number 2, okay? And we're gonna say proposers, that's that. And what does it return? Let's take a look. It returns, this is proposers. If you give it an index, it's gonna find the proposer, and within the proposer itself, it's gonna have 2 things. So it's gonna return a tuple. It's gonna have the name and the word count. Here we're trying to test for the condition, and which one do we care for? We care about the word count. But let's just put 2 of them together. So name, word count equals to this, and now we want to assert word count equals to how many? So this is 1 word from to himself or herself, and then there is the delegate, and there's a delegate. So in total there should be 3. So let's do an assertion here. So this is not required. We can just put an underscore. Let's go ahead now and run our test. And great, all our tests are there. So I don't believe we have tested for all of those things, but we at least have tested for the main wording, the constructor, the give rights to word, and the delegate. The word itself we haven't really tested. We did a few words here and there, but it's really not enough. You need to have more tests to complete this. So let me just do a Brownie test coverage and see where are we at right now. Oh, now it's also running that because we forget to specify the path. But now let's see. Give rights to word, 100% coverage. So give yourself a pat in the back. We did well. Delegate, that's probably 1 test missing. So I'll leave it to you to figure out where it is. You can leave it in the comment. You can leave it on GitHub if you figure out where that is. I can probably come back to this on the next video. But I really want to just have and just leave you with some room to exercise and to put this into practice, because if you watch me code and I'm just gonna do all of this for you, I don't feel like that's the best way to learn. So I just want to leave some of this. Word, we have 75% surprisingly, because we didn't actually even get to word. We were doing this from a top-down approach. And you realize this is kind of the way I test my code anyway. I go from top to the bottom and I scan it line by line, and I make sure that each one of every single piece of core functionality, there's an if-else statement, there's a require statement, any of this, I quickly write a test for that, right? So go ahead now and see how much can you complete, and try and see if you can get a higher coverage than 81.7%. But I'm gonna stop here, because what's gonna happen next is we want to deploy this onto a live blockchain, and we're gonna use this concept called testnet. So we're gonna deploy this to a live blockchain, so anyone around the world, they can go ahead and try and play around with our ballot, and I'm going to show you how to do that. So it's going to be really exciting, because now it's not sitting on your computer anymore. This blockchain is going to be there on the internet, and folks can go in there and interact with this ballot contract. So this is where I will stop. Go ahead, write the remaining part of the test, and I'll see you in the next episode. Remember to subscribe. See you. Bye.